Hello. More setting up word problems and solving them, just very specifically focused on ones involving percents. So we've worked with percents before, but now we're going to learn how to solve equations using them. So you'll notice that this always kind of turns into the same thing. The word of generally means multiplied by, and percent, we know percents are always out of 100. So 85% is 85 out of 100. The word percent literally means per 100. So all that is to say, if I say something like 85% of x, I mean 0.85 times x. Let's make that super clear. Right, if I ask you what 45% of 60 bucks is, you know already how to do that. You do 60 times 0.45. Is $27. And then go ahead and bust out a calculator because we're going to want to use a calculator for this section because we're going to be doing a lot of dividing by decimals. Okay, so let's look at some examples of what we can do with this. So it's a little too easy at this point for me to ask you what's 45% of $60, right? You just punch it into a calculator. So let's look at ones where we have to actually set up an equation involving an x. So the number 120 is what percent of 600? It seems like we've done this before, but we haven't done anything like this. We're finding the percent. So when we declare our variables and set up our equation, we want our variable to be the thing we're looking for, and we're looking for what percent. So our x is actually going to be a percent. So we have to write this in mathese. So 120 is what percent of 600? All right, let x equal the percent. And this means that like x percent of 600 is 120, or 600 times x is 120. Now the number that we get here is going to be a decimal. We're not like dealing with the fact that it's a percent yet. But just make sure that part makes sense to you. Some percent of 600 is 120. So of, right? X percent of 600 means 600 times x. So 600 times whatever this decimal turns out to be is 120. Okay, and now you know how to solve this equation. Just divide both sides by 600. 120 over 600, like I've been saying, go ahead and punch that into a calculator. Is 0.2. Okay, so that is not a percent. So at the end of these problems, you have to do a little conversion. So you just have to know that, right? It's not 0.2%. 0.2% is super tiny. That's 1/5 of 1%, right? You can look at it and say, well, it shouldn't be that tiny as far as a percent goes. So you know that to convert a decimal to a percent, you multiply it by 100, which for practical purposes just means you move the decimal place over 2. So that goes over 2 to the right, and that's 20%. Okay, so if we wanted to wrap it up, we would say the number 120 is 20% of 600, and that's easy to check. This seems the same, but it's different. 28 is 40% of what number? Okay, so now we're not saying, okay, what's 40% of 28 or whatever. We're saying something different. We're saying 28 is 40% of something. We want to know what the something is. We want to know what number that is, that we can take 40% of it and get 28. So again, just let x be the thing we want. So 28 is 40% of x. And then think about what I just said. 28 is 40% of x. That's a math equation right there. 28 equals 0.4 times x. 40% of x means 0.4 times x. Like that. Okay, now we're dividing both sides by 0.4. Go ahead and do that on a calculator. It looks weird, but when we divide a number by a tiny number like 0.4, it actually gets bigger. And think about why that is. 28% is 48, I'm sorry, 28 is 40% of some other number. That number should be big. that number is going to be bigger than 28 because 40% of that number is 28. And it works. So the number is 70. So what I'm telling you is that 28 is 40% of 70. Right, so just to summarize it there, and then that makes it easy to check. Just do 40% of 70 and verify that, yes, it is 28. So you have to be careful. In that problem, we were asked to find a number. In the previous problem, we were asked to find a percent. So we got this tiny little number of 0.2, but then we change it into a percent. If you're being asked to find the actual number and you know the percent, you're not going to have to do that. Okay, let's do a couple of these. You will definitely see stuff like this on the next exam. A new jacket costs $47.70, including 6% sales tax. What was the price before tax? Okay, so the price you bought it for, like the price you paid, was $47.70 because you had to pay sales tax. In Michigan, where we are, at least I think that's where you are, sales tax is 6%. Okay, so these ones throw people off. The 6% is of the original price. So like when you buy something for 10 bucks exactly, you take 6% of that, which is 60 cents, and you add it on. So it's like the 6% is of the thing we don't know yet. It's like the sales tax is 6% is something we don't know yet. So once again, just let our variable equal the thing that we're trying to find out. We're trying to find the price before tax. Okay, that's what X is. So we have, okay, we took X and then we added on 6% of X, right? And when we did that, we got 47.70. All right, so again, I'm encouraging you to write out the sentence that you're about to translate into an equation. X plus 6% of X is 47.70, because now you can really see what all that stuff turns into. X plus 0.06 times X equals 47.7. Like that. So for any kind of a sales tax problem where we're trying to figure out the original price, that's what your equation is going to look like. It's always going to look like that. It's going to be X plus some small percentage of X equals the actual price paid. Okay, so solve it up. X plus 0.06x, remember that's kind of like a 1x, so we can combine those like terms into 1.06x. You can kind of stop here and see that anytime you're adding 6% sales tax to something, that's going to equate to 1.06 times X. It's like you take the sale price and then the price you pay is actually going to be 106% of that. You can have percents that are more than 100, right? And that just means that they go up. So the price plus 0.06 of the price is always going to turn into 1.06. Okay, so that's where we're at. 1.06x equals 47.7. Remember, you don't have to put 0.70 because it doesn't do anything. And then just divide both sides by 1.06. Right, I was doing the thing before where I moved the decimal place over to get rid of all of the decimals. Now that we're doing this a lot, and I told you to use a calculator, you can just, you don't need to do that. That's really mostly for if I had you doing it by hand. For these kind of percent problems, at this point you're usually using a calculator. So just do 47.7 divided by 1.06. And you get exactly 45. So it's nice in math class when you get a nice clean answer like that, because you get the idea that it's probably right, because whoever made up the problem probably intended it to have a nice clean answer, right? So 45 bucks seems nice. And then it's easy to check that 45 plus 6% of that is going to be that 47.70. All right, so to summarize, the price before tax was $45. I'm going to do another one kind of a lot like that because these throw people off. So let me just be really clear right now. that 6% was not of this. The 6% happened before this. It happened in the past. The 6% is what made it be this. So it's 6% of something we don't know yet. So 6% of this number here is utterly meaningless, right? So if you tried it that way, it just wouldn't work, because 6% of 45 is different than 6% of 47.70. And either way, 6% of 45 is actually the real thing. The sales tax is based on the price before tax, okay? So just, like I said, follow these steps and work on just translating stuff like this into sentences like this, because then it's easy to take this sentence and turn it into this equation. That's like one of the more important things in math, is taking statements like that and turning them into equations. All right, same kind of thing. The math is going to be a little different, but if you're comfortable with this, go ahead and pause the video and try this problem. I would honestly encourage you to do that. If you can do this without me, then that's the whole point, right? But this is new, so you can just follow along. So a book is on sale for 25% off, and the sale price, so like the discounted price, is $63.75. What was the original price? So same kind of thing. That 25%. It's 25% of a thing we don't know. It was the original price, whatever it is, and then taking 25% off of that. So we don't know the original price, so that's what we're going to call X. Okay, and then that's our statement. X minus 25% of X is $63.75. Right? Whatever the original price is, we took 25% of that, chopped it off, meaning subtracted it, and now we know what we have. So that's easy to translate into math. X minus 0.25x equals 63.75. Here's the kind of thing we've seen before, and if you're clever and if you're confident, you can go ahead and do this. So notice that x minus 0.25x, when we combine those two like terms, it's 1 minus 0.25, which is 0.75. But you can just say, okay, something like 25% off of a number is the same as 75% of the number, and that's exactly what we have here. Whatever x is, 75% of x is 63.75. That's just another way of saying x minus 25% of x. So if you're feeling good, you can just jump right to here. Say 25% off is the same thing as 75%. Okay, I'm cool with that. Or do it this way. Right? I'm never going to punish you for doing too many steps. It's just we end up doing stuff like this a lot, and you notice patterns. All right, just divide both sides now, and just use a calculator. X is 63.75 divided by 0.75. You could do that by hand if you wanted, but you're not going to. So just smash it into a calculator, and then just always make sure that the answer you get makes sense. If you punch this into your calculator wrong, and let's say you got 850 instead because you were off a digit, I would really like to think that you would stop and be like, wait, the book was $850? What kind of book is this? And also, that doesn't make any sense that we took 25% off of it. Now it's only 60-some bucks. Right? So always make sure, if it's applicable, to make sure your answer makes sense to you as an intuitive thinking human being. Okay? So that's an okay number. You can certainly imagine a book costing that much. And that's it. And then just tell me. So for these, I am going to want you to write at the end what you just did. The original price, you can be as brief as possible. The original price was $85, and put a $ in there so there's units. And that's it. Okay, so those are percent problems. Thank you.